Welcome back, grade 12s. Finally, it's your part of the day. I know that you all are so excited. You guys are all screaming, yay, work and energy. Bruce, they're very excited. So I think what we're going to do, first of all, get those questions in, guys. Let's get them coming in. Bruce, over to you.
Right, Indiana, thanks very much. And guys, I must apologize to start. I've had a little bit of a cold and my throat's a little bit sensitive. So I think my voice might be sort of going a little bit up and down. So I do apologize
girly today,
hey? I'm sorry?
A little bit girly.
A little bit girly. It might be sort of going like this, but guys, that's what happens when the early winter season is starting, even though some people still think it's the height of summer. But guys, we're going to talk more about work and energy today rather than about biohealth. Guys, important thing, big section of mechanics, especially in the grade 12 exam, guaranteed a question somewhere along the line on work and energy. And what we've got to do today, guys, is make sure that we knuckle down those basics of work and energy. There's nothing more important than making sure that we've got the basics, the foundation settled, because then it doesn't matter how complicated the problem actually looks like or how it becomes and how the examiner tries to sort of confuse you. As long as you've got your basics in place, then there's absolutely no problem. So guys, what I'm going to do is go through a couple of the initial foundation concepts, make sure that we understand them, do a couple of problems with you. Indiana's going to have all the questions. She'll fire them to me when she's got a couple in, and then we can discuss it and we can have a chat, and just to make sure that we do understand. Okay, so guys, without any further ado, under the heading of work and energy, what are we going to have a look at? Well guys, the word work is something that we use pretty much in everyday life, don't we? We talk about homework, and we talk about people really working hard. And does that actually mean a physical work or mechanical work like we talk about in physics? Well, not all the time. It doesn't really mean that. However, there's one common thread that actually runs through it. And that is, whenever we do work, whether we are working hard on the sports field or doing a lot of homework, we have to put in an effort. Okay. Now, how does effort translate into mechanics, into physics? Well, an effort is always described through what is known as a force. So guys, when we do work, we have to have a force involved. So what I'm going to do is I'm going to draw an object on a flat surface, okay? And that object is going to have a certain mass, which I'm going to call M at this stage. And what I'm going to do is I'm going to show now an effort force, all right? And I'm going to make the force move to the right-hand side, and I'm going to call that my applied force. So APP standing for my applied force. Now guys, what's going to happen if I'm on that surface, and I'm going to assume a frictionless surface at this stage? There's no friction at all. We'll talk about friction a little bit later. If I apply a force on a frictionless surface, then what's going to happen? Well, that object is obviously going to move. And I'll just draw it in a dotted line like that. And it's going to end up in a position over here somewhere. So in other words, that applied force has caused the object to undergo a displacement, which I'm going to call delta X. Now, when we have a combination of applied force and that applied force causing that object to move, then we have work done in the system. And that's very important, guys. So my work done must be equal to the applied force multiplied by the displacement. Okay, and I'm just going to squeeze that in there. Sorry guys, I had to squeeze that in a little bit. Okay, so what's my work equal to? It's equal to my applied force multiplied by my displacement. And there, guys, is our very simple little mathematical equation to allow us to calculate the amount of work done. However, there are a couple of important things. Let me just scroll down a bit. There are a couple of important things that we must remember when it comes down to work. Okay, and that is, work is only done if the force is parallel to the direction of movement. Okay. work is only done if the force, and that's the applied force, sorry, let's just put that in there, and the applied force is parallel to the direction of movement. We have to make sure that we are always working with our force in the parallel to direction of movement. The second thing that we're going to have a look at is that work is only done if that object is moving. Okay, work is done only if object moves. Sorry, there we go. Only if the object moves. If the object does not move, excuse me, if the object does not move, if the object doesn't move, then we do not have any work being done. Okay. Now, the third thing that we must also be very aware of is that the force must constantly act on that object. So the force constantly acts on the object. Okay, right, so we've got three things we've got to keep into consideration. I'll just run through them again. The force must act parallel to the direction of movement of that object. Work is done only if the object moves. In other words, it covers that displacement. And thirdly, the force must constantly act on the object. If the force stops acting on the object, then the work will stop. Okay, and those are the three things we must take into consideration. Right, now, let's see how we can apply this now in a very simple type of calculation. So, let's extend the page down a little bit. I think, in fact, what I'm going to do, let me get a new page up. It'll be the easiest.
Bruce, before we go on, I just got to say something, because I'm very passionate about mindset learning this page. Like,
right.
This page is my baby. Can you believe that we've actually just reached 6,000? Not only have we reached 6,000 mindsetters on the page during this lesson, we've got 6,028. So during today's lesson, we've literally gone up like 300 people. So mindsetters, thank you so much for watching. And Bruce, back to you.
Well, we're getting all the stats coming in, and there's 6,000 people on the
it's incredible.
page.
It's incredible.
That's unbelievable. That must be one of the biggest sites around at the moment.
Yeah, especially in terms of education, guys. I don't think that there's anything out there like this at the moment. And not only is this platform for the learners, well, it's not only for us, it's for the learners to also use and to ask questions. And I see there's always the same guys that are answering questions. If somebody doesn't understand, sometimes I don't even need to even ask Bruce, because you guys are answering before. So that's fantastic, guys. Keep it up and well done.
Awesome. That's great, guys. Let's just get back to this. I want to do this problem quickly, and then we can probably take a couple of questions just to see how we are. Bit of a perception check. Right, so what I've got, I'm just going to redraw my diagram very simply. And I'm going to put an applied force. And I'm going to make that applied force 100 newtons to the right. Okay. So, what happens now if that object is going to move a distance of 10 meters as a result of that applied force? Well, as we said, guys, our work done is going to be my applied force multiplied by my change in displacement. And all we have to do is simply plug in a nice simple problem, 100 newtons, which is my applied force, multiplied by my displacement, and we can very easily see that 1,000 joules of work is done. Now, I've introduced a unit which I want to have a little talk about. I've introduced the unit of work which is known as the joule. Now, if we look at this unit very carefully, and I'm going to take it from, whoops, let's get another color. I want to get, let's go back to red. If I look at force and I look at displacement, we know from grade 11, even going back from those years, what the units of force and displacement are. Well, we know that the force is always measured in newtons, and I've actually used it up there already, and we know that displacement is equal to meters, and I used it over there. So if I say force times displacement, what am I actually saying? I'm actually saying newtons times meters, which we call the Newton meter.
Bruce,
Yeah.
would you be able to change the color of your pen?
Really, is the pen not, is it
Yeah.
not coming out all that well?
Everyone moans about the red. Maybe like a vibrant yellow.
Okay.
Or-
All right, I'll have a bash at yellow and we can take it from there.
Okay.
Okay. Right, so let's go to the yellow. Let's try that one.
Yeah,
Okay.
guys, let us know. I think
Let's
yellow will
see
be much
how yellow
better.
works. That looks a bit better.
Oh.
Okay. So guys, they'll be talking about the Newton meter. Now, I just want to extend the page slightly. There we go. Guys, the Newton meter is what we call the joule. Okay. And that's got a symbol that is given as capital J. Now guys, we must remember that joule, the name joule actually is named after someone, so we have to make sure that we do write it as a capital, okay? And you might have heard about the joule being used as a unit for some other physical quantity. And a lot of you will probably be jumping up and down and saying, well, isn't that the unit of energy? Well, absolutely correct. So if the Newton meter is equal to the joule, and the unit of energy is also the joule, then there must be a direct relationship between work and energy. And this is exactly what today's lesson is all about, is that we are actually looking at basically a direct transformation in terms of work and energy. And the important thing to remember is that when work is done, we always say energy is transferred. Okay, and I'll put a box over that. There we go. When work is done, energy is transferred. Now guys, that is probably one of our most important concepts when it comes down to work and energy. That they actually are one and the same thing. So if I go back to my calculation, there it is. 1,000 joules, okay? I've got 1,000 joules. What does that mean? Well, 1,000 joules of work is done, which means that 1,000 joules is transferred into some form of energy. Now, the big question is, what type of energy will it be transferred into? And I'm sure a lot of you will probably know the answer. It's kinetic. Kinetic energy. Now, what is kinetic energy? It's the energy due to motion or due to movement. And didn't I say that when a force is applied, the object must move in the direction of that force? Well, what's going to happen there is that when it moves, that motion is given into kinetic energy. Indiana, shall we take a little break?
Yes. Guys, let's take a little break, and then when we get back, hopefully Bruce will answer a few of your questions. I know we've got a lot to go through, so stay stuck to your seats, don't go anywhere, and we'll see you after the break.